So we're gonna use a cup and a string.
When
we pull it tight.
So
when we speak, the
string will vibrate and it will send the message to the other person. So go stand over
because the sound will go through the string, transmit, and into this cup.
No one can hear you.
Examples.
Hello.
Hello.
Sound travels faster through solids and when it's hot. And this is a solid, so it will travel faster.
So it traveled fast. A light wave passed through the window. You could see the transmission of light from outside through the glass window and into the room. Sound transmits through air. Sound is a mechanical wave, so it has to go through something, and in our case, through the gas state of matter. Hello, Vika.
Hello, Galina.
You see the sound goes through the air particles to her ear, and back and forth.
Really?
You can hear how the sound goes through air.
Sound is a mechanical wave, therefore it has to pass through something for it to be heard. It passes better through a solid and through warm temperatures. So here is Galina, who is going to sing to us, and she is speaking from the other side of half the wall and half the door, so it's a solid.
Right here you could see how the light is reflected from the window to the floor. Vika is going to explain to us absorption of light.
Well, every time that sunlight hits an object, it reflects back to our eyes to show us in color, right? So when the sun goes through this object, the object absorbs some of the light and it keeps it there so we can look at it and it reflects back to us and it comes back into our eyes so we can see the blue or the orange or whatever color it's showing. And the video, please.
This is light reflected from the mirror and back to the eye. Yes. We're gonna show you how you can reflect sound. Right now, the music is loud. Right now, it's louder.
Because of the closed area, so it bounces off the walls and comes back to our ears. Leave it in there for a little bit. Take it out. Do you see the difference?
Yes.
Put it back in.
As you can see, this is an acoustic room. Here, they record people singing or play an instrument or something like that. There are carpets on the walls and on the floor because carpets absorb the sound so that the sound wouldn't bounce off the walls while they sing or play an instrument when it's really loud to perfect the sound. Another example of absorption of sound is screaming into a pillow. The pillow absorbs the sound because the sound can't bounce off the walls of a pillow because the pillow doesn't have a wall and it's not a dense material and it's flexible, so it blocks the sound of going through. So if you're crying, you can scream into your pillow, no one will hear you. Dogs also absorb sound with their ears. For example, Hannah, they use their ears to absorb sound and send a message to their brain. Margaret, Hannah. Another good example of absorption of light is these little flowers. Well, they're not little, but yeah, pretty flowers. The light from the sun goes into the flowers, and the flowers take in the light and get this color.
For a sound wave, if the bigger the amplitude means that it's going to be the loudest, and the smaller the amplitude, it means it's going to be the softest sound. And for frequency, if it is very close together, that means high frequency, which is very high pitch. And if it's farther apart, then it's low frequency, so it's not high pitch. This, for example, has a high amplitude, so it is loud, and it's closer together, so it has high frequency, and it's going to be squeaky. This image that I just drew is the same as, well, almost the same as also high amplitude, so it's going to be very loud, but it's farther apart, so it's going to be a lower sound, so it's a loud, low sound. Almost the same, only the other one is closer together to make a high pitch, very loud sound. I'm filming this for Galena because at this moment she is editing our video, but she made these diagrams and I'm just going to explain for it. So, for the first sound wave, as you can see, it has low amplitude, so it's not loud, it's quiet, and it has low frequency, so it's low pitch, so it's like... This one, over here, has also low amplitude, which means it's quiet, and it has high frequency, which means it's high pitch, so it's like... Thank you for watching.